Good afternoon, everyone. We're just waiting for a few more to join. We'll start around 1, just after 1. Thank you. It's 1 o'clock now, Terry. Do you want to give people a couple more minutes?
Yep, we can do that.
Yeah, okay. Thanks for bearing with us, everyone. We'll just give people a few more minutes to join. Thank you. Sorry, I'm conscious many people are on their lunch hour. Shall we just start and then others can join us as they arrive? Is that okay? Wonderful. Thank you.
All right. Thanks, Anne-Marie. All right, so welcome everyone to this live taster webinar session on Introduction to Data Analytics and Visualization. Of course, this module is a part of our new MSc in Accounting Analysis and Sustainability at Durham University Business School. So my name is Terry Harris. I am the program director and module leader for this particular module, as well as I'm program director for the MSc in Accounting Analysis and Sustainability, and module leader for the module Introduction to Data Analytics and Visualization. So before we begin, I'll just give you a brief snapshot of myself, some background about myself. So I have an MSc in Computer Science and Accounting, Masters in Computer Science, where I specialize in machine learning. I have a professional designation in accounting with the ACCA, and I have a PhD in finance. Of course, I'm an associate professor at Durham University, and my research interest is essentially revolves around the use of analytics, so AI, machine learning, analytics, the use of analytics to solve problems in accounting and finance. So that's a brief picture of what I'm like, my background. and my interest in analytics, particularly accounting analytics. So the agenda for today is as follows. First, we'll discuss the program. So I'll give you some background as to what the MSc in Accounting Analytics and Sustainability is all about. Why data analytics is important. Of course, you're all here because you're interested in data analytics. So I wouldn't have to explain this too much, but we'll discuss what it is and why it's important. And then I'll give you a brief overview of our module. Our module essentially recites three main themes: descriptive analytics, predictive analytics, and data visualization. So I'll give you a brief taster of these three themes for our module. Then I'll point towards some key dates that you need to pay attention to. Of course, the deadline for applications and so on, some key contacts, and how you can go about applying to our master's program. So about this program, of course, this program will enhance your skills in data analytics, machine learning, artificial intelligence, as they relate to the related fields, in fact, of auditing, accounting, and finance. And also in our program, you'll also enhance your knowledge of sustainability issues, particularly integrated reporting, environmental, social, and governance issues, etc. Right? So this is the program. This is what it's essentially all about: enhancing your skills in essentially data analytics and AI, and how they relate to accounting, finance, and auditing. The program is very flexible, so we have designed the program to enable flexible online study. This means that you don't have to quit your job. You can continue working while studying with us online. We fully satisfy all CPT requirements with respect to the three main exit points for the program: the certificate in accounting analytics and sustainability, diploma in accounting analytics and sustainability, and our MSc. So we have fully satisfied the CPD. And also, if you take our program, you'll build a network of individuals who are like-minded. So you'll get to meet a network of individuals who are like-minded, who are interested in how analytics, AI, machine learning, how these are impacting upon and helping to improve and enhance the related fields of accounting, auditing, and finance. So this is all the advantage of course, pursuing our program. Flexible study, continue to work and live wherever you are, while enhancing your skills in machine learning, analytics, and how they apply to accounting and finance. And of course, satisfying your CPD and building a network of like-minded individuals. The program has three main phases. In the first phase, you can pursue the certificate in accounting analysis and sustainability. In the certificate, you have to complete three modules: introduction to data analysis and visualization, modules I'll talk about myself, sustainability and ethics, introduction to machine learning and artificial intelligence. This is another module that I cover, sustainability and integrated reporting. So these four modules comprise the first phase. So the certificate in accounting analysis and sustainability. In the second phase, we have the diploma, the postgraduate diploma in accounting analysis and sustainability. In order to complete the diploma, you have to complete the following modules: natural language processing and textual analysis, sustainability assurance analytics, robot process automation, and research methods and design. And then the final phase, which allowed to achieve the full master's in accounting analytics and sustainability, requires the production of a research project. This is essentially a dissertation. Of course, today we're going to be focusing on the first module, just give you a brief overview, high-level view of what the module Introduction to Data Analysis and Visualization, what that module is all about. So what is this, why are we interested in it? Of course, data analytics involves the use of statistics, which some people are afraid of, but in our module, we make it very easy. So it involves use of statistics, technology, quantitative methods to enable our organizations to unlock value or gain insights from their data. And of course, data are facts and figures about the real world. In our module, we'll explore the main themes of analytics. These involve descriptive and inferential analytics, and also predictive analytics. Also in our module, we'll demonstrate how to perform these forms of analytics using Excel and RStudio. So you get hands-on technical skills in how to create various descriptive statistics and descriptive analytics, predictive analytics, so different types of regression models and so on, using Excel and also using the programming language R and RStudio. We'll also discuss how to create visualizations in our module, so how to create dashboards and different types of visualizations that can help you to communicate key insights about the data to decision makers. So why is data analytics important? So we saw what it is, Why is it important to us as accountants and individuals who are in the business-related fields? Of course, recent years have seen a rapid increase in data across and the use of AI across businesses and governments. And I don't have to tell you about that. You pay attention to the news, that large language models, we've seen a growth in data. They're being used and implemented in businesses and governments across the world. And it's important that us as accountants that we have some of these skills. Accountants and business professionals in general need to have these skills in data analytics and visualization, because the business world, as you well know, is demanding hybrid professionals that have their peculiar expertise. In accountants, you understand how the financial statements are constructed, so you have that expertise, but you also need to now pair this with some knowledge of how to create various types of analytical models, so descriptive and predictive analytic models. You also have to pair this with expertise in data visualization, so how to effectively communicate insights drawn from those data to decision makers. You have to create dashboards and engage in storytelling. So we know this is the case, and this is why data analytics, particularly in accounting, makes sense and is important. All right, so here's a brief overview of our module. Our core topics and themes of our module are as follows. We discuss descriptive and inferential analytics. In this part of the module, the first 4 to 5 weeks, you take the following topics: descriptive statistics, sampling, hypothesis testing, confidence intervals, statistical inference. And of course, all of the examples will be drawn from accounting and sustainability related data. And this will make it easier to understand, because all of the data and examples are drawn from our field, from business related fields. In the second phase, or second theme of the module, recites predictive analytics, where we're discussing, or we will be exploring the themes of forecasting, so how to forecast things like sales, linear and multiple regression analysis, how to create multiple regression models, panel data models. These are the main topics that we'll cover in predictive analytics. And then finally, we'll discuss data visualizations, where we'll be discussing the best practices for constructing dashboards and telling story using data, telling stories using data. We also will be making extensive use of Excel and RStudio. Very often we see in the marketplace, you see courses that discuss data analytics in Excel and then data analysis in R, RStudio, or Python. In our module, you'll get exposure to both. So if you're interested in pursuing data analysis in Excel or in RStudio, you'll have examples of how to implement various types of analysis using both Excel and R. So you get a 2-for-1 there, right? So data analytics in Excel and also data analysis in RStudio. All right, so the first theme of the module, here's a high-level view: descriptive analytics. Of course, this involves trying to understand historical data to better understand the decisions that were taken using those data. So data analytics involves the analysis of historical data to better understand that data and the results of past decisions that were taken using that data. Descriptive analytics usually begins, like with all forms of analytics, with the production of descriptive statistics. And these are measures about the data, right? So these are important summary statistics or summary measures about the data. If the data is recites the population, so all items of interest, or a sample set of the data. So whether the data is a subset of the population. So descriptive statistics are measures that summarize important features or statistics about a population. So the data is a population, all items of interest, or a sample, a subset of the population, often with a single number. They provide sample summaries of the population or sample in terms of measures of location. So this is the center of the data set. Measures of dispersion, so how spread the data set are, and measures of the shape of the distribution of the data. So this summary statistics, so we're thinking things like means, medians, modes, variance, standard deviations. As accountants, we're producing data, and if we are analyzing this data, we need to often find some way of summarizing the data. Very often when we're taking a decision, you're not able to transfer all of the data to the decision maker. We have to give them some idea of what the data are like, And in order to do that, we need to provide them with some summary statistics. So what is where is the center of the data? What's the average, say, customer age? Or what is the dispersion of the data? Things like that. So more on these various descriptive statistics. So we have measures of location or measures of the center of a distribution. So these provide a single value that in some fashion represent the center of a data distribution. So here we have a distribution, a symmetric looking distribution, and the usual measures of the center of a distribution, so the center would be around here, would be the mean or the median, right? So the mean, obviously the arithmetic average, and the median, the 50th percentile. These are measures of a center of a distribution. So we have some distribution and we have the center, right? We also, with respect to descriptive statistics, we also discuss measures of dispersion. So how spread or compact the data are. These are measures of dispersion. Not all data distributions have the same dispersion. Here we have two distributions in the graph. We have the light green and the light orange distribution. They both have the same, essentially the same mean, median. They're both symmetric distributions, but the green one is more compact. So the observations are more closely close to the center on average, and the like orange distribution, this is more dispersed or there's more spread, right? So we have a great degree of variation in the like green, even though they have the same mean and median statistics. We also, in our course, discuss and teach you how to compute measures of the shape of the distribution. So we have measures of shape of distributions. Here we have the distribution that's fairly symmetric. In fact, it's normal. This is a particular type of distribution that's normal. And then we have different types of distribution. So distribution need not be. A distribution can also have fat tails or more observations than would be normal, right? So more observations in the extremes than would be normal. So we discuss how to compute and create visualizations for various measures of the shape. These help us to understand whether the distribution is symmetric or skewed. So here we have, again, a symmetric distribution, bell shape. This distribution is skewed, or whether it's peak or flat. So whether we have more observations than would be normal in the tail or less in tail than would be normal. The usual measures of the shape include skewness and kurtosis. So we discuss skewness and kurtosis, how to compute these, how to create visualizations like the ones you see on the slide. And that essentially completes our discussion of descriptive analytics. So of course, we discuss a lot more things. We discuss in the course some inferential statistics, so hypothesis testing, confidence intervals, and so on. But that's just a taste of the type of techniques that you'll get familiar with, both implementing them in Excel and in R. Next theme that we're going to discuss, and the next main theme of our module, is predictive analytics. So the main focus of predictive analytics is to predict or forecast the future by examining data that's obviously recited in the historical record, right? So we're trying to examine historical data in order to detect patterns and relationships in these data and to extrapolate these patterns and relationships forward in time to make predictions or to understand relationships. There are two main types of forecasting approaches. These involve qualitative forecasting approaches. These are usually based on some expert judgment or some event that occurred in the past that's similar to what's happening now, and quantitative forecasting techniques. These involve the use of statistical models to essentially predict the future or project into the future. So with respect to qualitative techniques, there are two main approaches that we discuss in our course. The historical analogy. Here we focus on obtaining the forecast in the future by looking at some historical event. You know, they say that past is prologue, right? So, you know, history rhymes, all these things that we know. Here, you're looking at the historical record to find a very similar event that occurred and see what insights you can gain from that event to bring it into the future. So we discuss in some detail historical analogy and how we can go about ensuring that our historical analogies make sense. We also discuss the Delphi method. This is a type of qualitative forecasting technique that involves the impaneling of experts. So we have a panel of experts and we query these experts in order to converge on some opinion. So this is like a particular type of approach where we have like a panel of experts and we query them. So for instance, if we are facing some, as a company, facing some lawsuit, are we being sued, and we'd like to know, okay, well, should we provision for this or not? How likely is it that, you know, this particular lawsuit will be successful? You know, we probably panel a series of senior lawyers, so maybe like King's counsels, and, you know, query, we'll present them with the evidence from the case and maybe converge on their expectation, their best guess as to whether we will actually face a judgment, and therefore we should provision for this judgment, or whether you know, the case is probably going to be ended in our favor. So the Delphi method. And also in our course, we discuss a series, and we take a lot of time to explore a series of quantitative forecasting techniques. So these involve moving average models, simple linear regression models, autoregressive models, multiple regression models, and so on, right? So we have, we discuss, we spend a lot of time in weeks, say around weeks 6 to 8, discussing these methods: moving average, simple regression models, so simple regression models, autoregressive models, and multiple regression models. With respect to moving average model, this is a simple smoothing method that can help us to forecast some future maybe sales or some future event, so maybe future sales. And we particularly use the moving average model when certain conditions are met. So when we don't have a significant trend, seasonality or cyclicality in a data set, we tend to use, or we can use, a moving average model. So on the right, we have 3 processes. We have a process that's fairly stationary. And by stationary, we explain this in detail in the course, and it more or less suggests that it has a constant mean over time in terms of the process, and the dispersion is also pretty constant. So this is Gaussian white noise, which is, you know, stationary process, mean of 0 essentially here. And we have another process that recites cyclicality or seasonality. There's an oscillation over time. And then we have a third process that recites a trend. So this is a trend upwards, right? So if the process recites very limited cyclicality or seasonality, so it doesn't oscillate a lot, and doesn't recite a significant trend, then the moving average model is an appropriate model to use for forecasting. So we discuss in a lot more detail, you know, how to go about implementing the moving average model, and of course we give you some code in R and help you to implement moving average models in R, and also discuss how to perform the same type of analysis in Excel. We discussed the simple regression model. So simple regression model, we can apply this for forecasting, particularly if the data recites a trend. So if there's a significant trend in the data, then maybe moving average model is not, simple moving average model is not appropriate, and we should use some type of regression type model. Here's a simple regression model that we can use to estimate, say, maybe again, future sales, given a time variable, right? So given some time index. So here we have a simple linear model where y is the outcome you're trying to predict. So maybe that's sales, in this case, for this data set, coal production. So we're trying to predict coal production as a function of time. So beta 0, B0, this is the intercept. B1 is a slope coefficient. X is a variable that is an index of time, in this case, year. Is our X variable, and epsilon is just the average term, right? So we have a simple regression model which we can use if our time series, if our data set recites a trend. So here we have a increasing trend. So we have coal production is increasing in years, well, in a total amount as the years increase. So this is a positive relationship, and we show how to build models like those. We also discuss autoregressive models. Autoregressive models are appropriate in circumstances where we have some degree of cyclicality or seasonality, so where there's some persistence in the data. So when our models recite autocorrelation, so there's some persistence in the data, this is to say that large observations are followed by other large observations, and maybe small observations are followed by smaller observations. When that's the case, we tend to implement autoregressive models, and in our course we discuss autoregressive models. You know, here the outcome y is the contemporaneous or current value of the outcome that we care about. C is an intercept or constant. Phi is a coefficient that's associated with the like value of the outcome. And of course, epsilon is the error term, right? So this is a standard equation for autoregressive process, and we discussed in our module autoregression and autoregressive processes and when to implement them when it makes sense. Also in our module, we discussed multiple regression forecasting. So multiple regression models are often used for forecasting when the time series is exhibiting some seasonality or some or when we have some causal variable that we want to include on the right-hand side. So we have multiple regression models. So we have multiple variables X on the right-hand side of the equal sign, right? So we have the equal sign here. The left-hand side is the outcome Y that we're trying to predict. On the right-hand side, we have essentially the predictor variables or the independent variables. Again, we have an intercept, beta 0 or B0, the various slope coefficients, B1, B2, up to Bk that are associated with the X variables. These are the independent variables or the predictor variables. When the data set recites seasonality or cyclicality, we can implement a regression model where the seasonal effects are captured by the betas and are indicated by variables that are dummy variables that are coded one for the seasonal time periods. And we can also implement a multiple regression model in instances where we have a causal variable. So some variable we think is going to lead the impact on the outcome variable. So some variable that's leading and is going to impact on the outcome variable. So for example, if you're trying to estimate gas use, so gas use, we know gas use is cyclical. In the summer months, individuals don't heat their homes a lot, so we have essentially minimal gas use. In the winter months, as people turn on their boilers, we have more gas usage. So if you're trying to predict or build a model to predict gas usage, this gas usage data series recites seasonality, and we should build a model that includes or is able to capture these seasonal effects. So one way to do that is to include a variable X, index for time, and also dummy variables that capture the effect of being in February or not, March or not, April or not, and so on. So we have a series of dummy variables, and we'll be including all of them on the right-hand side. So we're building a model like this. We're estimating the effect of gas usage on a constant time index variable and a series of dummy variables that capture the effect of being in February, March, April, up to December. Of course, we're ignoring January because we want to avoid a problem called perfect collinearity, which we discuss in the course, right? So we want to avoid perfect collinearity, so we drop one of the months. But this is an example of a regression model that multiple regression model that we can build and that we'll discuss in the course using, again, Excel, and we can also use R to do this. That helps us to predict gas usage as a function of time and the various seasonal effects, or monthly effects in this case. We also implement multiple regression models if we suspect that we have a causal relationship between some variable X and the outcome Y. So when we have some factor or feature that we think has a causal relationship with the outcome that we care about, we can also build a multiple regression model where we include that factor or feature on the right-hand side of the equal sign. So for example, suppose we want a model to predict future gasoline sales. If we're predicting future gasoline sales, the average price per gallon, this is going to be an important factor, as most customers will tend to consume less as the price increases, right? For most rational customers will tend to consume less as the price increase, all other things being equal. And so if we know the price per gallon, and the price per gallon would usually precede sales, and we know the price per gallon of gasoline before sales comes in, because if we're in the business of selling gasoline, so we're a gas station, we know the price that we're going to price the gasoline at, and that will precede, of course, sales. Then there is a causal relationship, or we should suspect a very strong causal relationship between price per gallon and sales. And so if that is the case, then we should include price per gallon on the right-hand side of any model that seeks to predict sales. Right? So we'll discuss how we can identify these variables that we think could be causal or to have causal relationships, how to test to see if our suspicion that the variable has a causal relationship with the outcome Y, whether that suspicion or it is valid or not, and how to estimate these type of models. So here we're regressing sales. So this is gasoline sales on a constant the variable week that captures the index of time again. So week 1, week 2, week 3, and then the causal variable price per gallon, based on the idea that, as time goes on, people may consume more or less gasoline. And also, as the price per gallon increases, maybe the sales declines. Like with most rational economic products, there should be this inverse relationship between the level of price and the quantity demanded, right? So, right, so that's forecasting. So we spent a lot of time on building models like these, discussing linear regression models. We also discuss in a lot of detail panel data models, so fixed effects, random effects models that I've not talked about here, but we spend a lot of time on panel data models, and when it's appropriate to use various types of panel data models like fixed effects models, random effects models, how to test whether fixed effects and random effects models are important or are appropriate or more appropriate. And we also discuss some other types of like panel data models in general. All right, so the last part of our course and last theme for the presentation today is on data visualizations. So also in our course, we spend a lot of time on data visualizations throughout from weeks 1 to weeks 10. We are every week producing visualizations in Excel and in R. So we produce visualizations all throughout. But in week 9, we focus specifically on data visualizations. So the best practices for constructing various dashboards and how to tell stories using data. Right? So this is essentially throughout the course, but and also specifically recited in week 9. Of course, data visualizations. This is the presentation of data in a pictorial or graphical format. This enables decision makers to quickly understand what's going on to get the key insights that will inform their decision. When developing visualizations, we tend to consider pictorial superiority, cognitive load. We want to reduce cognitive load, and we try to include as many as possible pretty attentive attributes in the visualization to help individuals to understand what's going on without them having to think too hard. All right, so the first, picture superiority. I mean, we know the saying, pictures worth 1,000 words, and that's true. As a human animal, we have, essentially, we have very complex, very fast visual cortex. We're trying to avoid lines, they say in fast. So, we can see, and we process a lot of information by our visual cortex. And seeing is a lot easier and a lot faster than thinking. Right? So thinking is slow, seeing is fast. And so if we have a lot of key insights that are recited in the data, and we like to internalize these key insights and communicate them effectively to our decision maker to give them knowledge, one of the quickest and most efficient ways to do that, I'm sure you know this already, but is to create some form of visualization that can communicate the key insights quickly to them and that they can process very fastly, very quickly, using their visual cortex, right? So data visualizations, this is about using pictures, so visual charts and to present data. This is very fast compared to thinking about data. When we're developing visualizations, we need to think about the cognitive load. This concerns the amount of mental effort it takes the user of the information to understand the information that is presented. We want to minimize cognitive load while still communicating the key ideas. So now we have like a cockpit, and there's a lot of stuff going on there. We like to reduce clutter. So one way to reduce the cognitive load. So we want to reduce clutter in our visualizations while keeping the main and key ideas. And we also want to make use of pre-attentive attributes. So this is another way to get information into the brain immediately, is to have the user focus on various aspects of your presentation without telling them to focus on that aspect of the visualization. So for instance, if I were to ask you, count the number of 4s, how many 4s do you see? I've not made that task easy for you, right? So there are essentially 5 4s here, but it's not an easy task. I've not made it easy, right? So you have to actually look through and say, okay, well, it's 1, 2, 3, 4, 5 fours. If I answer that question again, having highlighted the fours and ask you to count the fours, of course, without me even asking you to do that, you can immediately see there are 5 fours there, right? So, and of course, this task is a lot easier the second time around. If I ask you count number fours again, you can immediately see using the bold, using a darker color. So we have the numbers in gray, but using color, so darker color and highlighting them bold, you can immediately see that there are 4 fours. I'm sorry, 5 fours there. And of course, if that was an important piece of information to communicate to you that there are 5 fours in this particular series of numbers, then I could immediately communicate that by highlighting them as opposed to just presenting them here as I've done before. Right? So this is not very useful in communicating the number of fours to you quickly without having you to think. But this particular visualization is. And of course, this might seem trivial, but that's the point, right? The point of pre-attentive attributes is to have the audience focus and instantly receive information without having to tell them to focus on a particular aspect of the presentation. All right, so that's our overview of the course. So of course, we discuss descriptive analytics, predictive analytics, and visualizations in a very brief overview. At this point, is over to you. If you have any questions, you can pop them into the chat, and Anne-Marie will field them for me, or you can answer them, and we'll try to answer your questions at this point, and then we'll try to wrap up the presentation for today. Any questions?
None so far, Terry. No, we have any questions to ask Terry today?
Somebody has the hand raised, Anne-Marie, I think.
Okay.
Are we able to?
Yeah, let's see.
Cindy.
Good afternoon, everybody. Thank you so much for this informative session. I'm happy that I was able to dial in. I just needed clarity around, at what level would you expect, the candidates or the students to be? Is this something where maybe someone is usually on the board, being chairs of audit committees, where they've already basically transcended a space of being a CFO or of being someone who works in the engine room, to also register for this course, or this is more for accountants and auditors who work with the detail, work with, with the numbers. So just to get some clarity around that. And also, I might have missed the cost of the course. Thank you.
Yeah, so just thanks for the question. So we're pitching it at primarily at those accounting professionals, so people pretty much still in the engine room who are working with the numbers and need to produce visualizations for, say, higher management. So that's the general audience that we're pitching at. Of course, individuals who are in those higher strata of management will still get value out of the course, because they would also understand how the models and visualizations that they are seeing, how those are constructed. So yeah, so we're pitching it at executives, say middle level executives, individuals who are still producing data, so CFOs who have to present to their boards, senior accountants, and so on, pitching it at that level. But we think that everyone can get benefit from the program.
And just to pick up on the programme fee, Cindy, it's £3,900 per year for home students, which would be UK students. International students, it's £5,400 per year. The university does allow sort of split payments, and you can break that down into, I believe it's up to 8 equal payments across the year, just to spread out the payment plan. Okay.
Thank
Terry,
you
we
very
have a
much.
question.
Much appreciated.
Thank you. You're welcome. You're welcome.
Thank you.
We have a question here from Ram Kumar, which says, after the MSc, what are the career options for accountants?
After completing MSc, well, you can continue to work in accounting, or and we've had students in the past who've done this, transition into the data science fields. We've also have students that have taken, say, our undergraduate course. We have an undergraduate course called Data Analytics. They're accountants, and they have to transition not too far away from accounting. We have individuals working at Bloomberg and so on, but they're working more in the technical aspects of modeling. So you can continue working in accounting, but we suspect that many students, once they graduate, will maybe transition into more like data analyst roles, and roles like these that are associated with that might make use of accounting data, but are making more heavy use of the techniques that we're covering in the course.
Thank you. And we have a question now coming in from Evans. I've just allowed your camera and mic, Evans.
Hi, yes. Thanks, Terry and the team for this presentation. So just a quick one. So if somebody is looking at doing the MSc program, looking at it might include some form of coding. So would there be a refresher course on some coding, or the person needs to have some basic skills in coding before he can enroll on such course?
Right, so we don't assume any understanding of coding. So I've taught in accounting education for a long time, and accountants are not really usually trained for coding. So we're going to take you through how to actually create some scripts, again, in R, and all of the assignments are paired with Excel exercises or Excel. So you can complete your assignment in R or Excel. If you feel more confident coding, you can use R. If you're not as confident, you can use Excel, and all of the examples, everything makes use of both. But what we intend to do, and we do not assume that individuals have any prior knowledge of programming or scripting or coding, and we'll take you through to actually complete all of the assignments using R. We will provide starter code. In fact, we have a lot of starter code available, and I'll be explaining this code in class. So I'll explain in detail how the code is constructed. And by seeing the code and by seeing how it's constructed and by working with it, you will be able to, at the end, piece together your own script to do some analysis that you care about. And in fact, this is the main flavor of the summative assignments, where I've given in the weekly workshops some data and some scripts in R, and I explain how these scripts work and how they perform the type of analysis that you're performing. And then with the summative assessments, you essentially just have to put things together and create your own script.
Right. Thank you so much.
Thank you, Evans. Any other questions from anyone? Or any last pointers you would like to point out about the program itself, Terry?
Thank you. Yes, so just to wrap up, so here are the key dates. So the program starts this October 2025. Applications are open now. Please apply before July. So please apply before the end of July. If you have any questions, feel free to reach out to myself, either on LinkedIn or via email. We have our head of department, Professor Amir Michael. You can reach out to him via his email account, or via LinkedIn. And Marina Van, you can reach out to her. And of course, Catherine Kirby, you can also reach out to her as well. So these are the key contacts. How to apply? You can apply via our website, so the program website. Just go to the following URL or just search Accounting Analytics and Sustainability Durham University. You'll find it on Google or wherever, and just click on it and complete the application. Like I said, application is open now, so you need to apply immediately. If you require any additional support, please feel free to reach out to our executive education team or our admissions team, right? So if you have any issues with admissions, you can reach out to our admissions team, executive ed, and so on. Right, so at the very end, I'd just like to thank you for joining this taster. If you have any other questions, you can ask them now. We have about 2 minutes left. I'll be happy to ask them. If not, you know, I wish you well, and you know, I'll see you guys soon.
Thank you, Terry. We've got one last question just come in from Kays. What are the costs involved? So just to confirm, and in case you didn't hear earlier, it's £3,900 per year for UK students and £5,400 per year for international students. And they can be broken down and paid into smaller chunks. I think it's up to 8 equal payments per year. So you can, it makes it more affordable. Catherine and I are more than happy to speak to anyone individually. If you would prefer a Teams call or a phone call, just reach out to us and we can answer any individual questions you may have. We appreciate some people don't like to ask them in an open environment, but we're very happy to meet with you after this and discuss any questions you may have. And also with the applications, we'll send you out a link to the application portal to help with that. If you've got any questions throughout the application process, do reach out to us and we can help you with that too. Okay, it's 1:45, so we've managed to do that on time. I guess most of you are returning to work, depending on where in the world you are, but we wish you a lovely rest of your day. We hope to receive your application soon. Thank you.
Bye.